Today is the fourth lecture of complex number. So yesterday we are on some properties of moduli. First theorem, yesterday we have proved that the modulus of product of two complex numbers, the product of their moduli, if we have Z1 times Z2, then it will be modulus of Z1 times modulus of Z2. Okay. So now we move to second one. We have done yesterday this one. So we move to second one. So theorem 2. The modulus of the sum of two complex numbers is less than or equal to sum of their moduli. The modulus of the sum of two complex numbers is less than or equal to sum of their moduli. That is Z1 plus Z2 modulus is less than equal to modulus of Z1 plus modulus of Z2. So now you can see how we can prove it. So let Z1 equals R1 e to the power I theta 1, Z2 equals R2 e to the power I theta 2. Then Z1 plus Z2 will be R1 e to the power I theta 1 plus R2 e to the power I theta. We can write it like that cos theta 1 plus I sin theta 1 plus R2 cos theta 2 plus I sin theta. Now we can write it like that R1 cos theta 1 plus R2 cos theta 2 plus iota R1 sin theta 1 plus R2 sin theta. So this is the value of Z1 plus Z2. Now taking the modulus both sides. So we get modulus of Z1 plus Z2 will be square root of R1 cos theta 1 plus R2 cos theta 2 whole square plus R1 sin theta 1 plus R2 sin theta 2 whole square. So it can be written as R1 cos square theta 1 half plus R1 square sin square theta 1, so it will be R1 plus R2 square plus twice of R1 R2 Twice of R1 R2 cos theta 1 cos theta 2 plus twice of R1 R2 sin theta 1 sin theta 2. So now it becomes modulus of Z1 plus Z2 equal square root of R1 square plus R2 square plus we can take 2 R1 R2 as common. We get cos theta 1 cos theta 2 plus sin theta 1 sin theta. And we know that this is the formula of cos A minus B. Means cos A cos B plus sin A sin B sin cos A minus B. So it becomes square root of R1 square plus R1 square plus R2 square plus 2 R1 R2 cos theta 1 minus theta. We know that cos theta 1 minus theta 2 is less than equal to 1. So it becomes square of plus R1 square plus R2 square plus 2 R1 R2. So it implies it is R1 plus R2 whole square, and this is square root of this. So this becomes R1 plus R2. That is modulus of Z1 plus modulus of Z2. R1 is modulus of Z1 and R2 is modulus of Z2. So consequently, modulus of Z1 plus Z2 is less than equal to modulus of Z1 plus modulus of Z2. We can prove it if we have more than two complex number and the same rule is applied. So we can use by induction. We can write it By induction, it follows that Z modulus of Z. So now we move to third theorem. A modulus of difference of two complex numbers is greater than or equal to difference of their modulus. So theorem 3. The modulus of the difference of two complex numbers is greater than or equal to the difference of their moduli. So proof, let Z1 equals R1 e की power I theta 1, Z2 equal R2 e की power I theta 2. So here modulus of Z1 R1 modulus of Z2 is R2. So now Z1 minus Z2 will be R1 cos theta plus I sin theta minus R2 cos theta plus I sin theta. We can write it R1 cos theta minus R2 cos theta plus iota R1 sin theta minus R2 sin. This is theta 1, this is theta 2. This is 1, this is 2. Now the modulus of Z1 minus Z2 will be square root of R1 cos theta 1 minus R2 cos theta 2 whole square plus R1 sin theta 1 minus R2 sin theta 2 whole square. We can open this. So we get R1 square plus R2 square minus 2R1 R2 and cos theta 1 minus cos theta. Now cos theta 1 minus theta 2 is less than equal to 1. So minus cos theta 1 minus theta 2 will be greater than equal to minus. So it will be greater than equal to R1 square plus R2 square minus 2 R1 R2. That is, it is greater than equal. R1 minus R2, that is modulus of Z1 minus modulus of Z2. So thus we prove that modulus of Z1 minus Z2 is greater than equal to modulus of Z1 minus modulus of Z2. Hence proved. Now we move to next. To prove that modulus of Z1 plus Z2 whole square plus Z1 minus Z2 whole square equals twice of modulus of Z1 whole square plus modulus of Z2 whole square. So let Z1 equals R1 e की power I theta. Z2 equals R2 e की power I theta 2. So modulus of Z1 is R1, modulus of Z2 is R2. Now Z1 plus Z2 will be R1 cos theta 1 plus I sin theta 1 plus R2 cos theta 2 plus I sin theta. It can be written as R1 cos theta 1 plus R2 cos theta 2 plus iota R1 sin theta 1 plus R2 sin theta. Now modulus of Z1 plus Z2 become square root of R1 cos theta 1 plus R2 cos theta 2 whole square plus R1 sin theta 1 plus R2 sin theta 2 whole square. So this becomes R1 square plus R2 square plus 2R1 R2 cos theta 1 minus theta. Likewise, we find Z1 minus Z2. And we find the earlier, so we obtained square root of R1 square plus R2 square plus minus 2R1 R2 cos theta 1 minus theta 2. Now Z1 minus Z2 whole square will be R1 square plus R2 square plus minus 2R1 R2 cos theta 1 minus theta. And from here, Z1 plus Z2 whole square will be R1 square plus R2 square plus 2 R1 R2 cos theta 1 minus theta. This is equation first, this is equation second. On adding these two, we get Z1 plus Z2 whole square plus Z1 minus Z2 whole square will be twice of R1 square plus R2 square. And R1 square is modulus of Z1 square. This is modulus of Z2 square. Hence, bro. So it is enough for today. So we will continue tomorrow.